Hey guys, in this video I'm going to take a closer look at the General Electric wireless remote control I picked up recently off of eBay. This should work with a coaxial TV that I also got recently from a friend. It's still out in the garage, but I do hope to get that TV up inside sometime soon and try it out with this remote. But in the meantime, I want to pop open this remote, examine it, and try powering it up, and we'll take a look at the schematic for it too. Looks like there are just a couple screws inside holding it together. Oh, and let's look at the info on here too. This device manufactured 9-59, looks like, so maybe September 1959. Can be expected to comply with the requirements of Part 15 FCC rules when operated without departure from the instructions and specifications of the manufacturer. And that's probably a serial number, 26067. Does that mean they made 26,000 of these? Not sure. For most effective operation, point either end of case towards TV receiver. To adjust volume, hold down volume plus button for max volume. Adjust TV receiver volume control to slightly above normal volume. Volume may now be controlled remotely. So they're saying you should point this towards a TV, which would be a little goofy. I guess so you would operate it like this rather than like this. Assuming the TV's straight in front of me, you should either hold it like that or like that while operating. Alright, so let's see what's inside. Just a couple flathead screws. Wireless remote control transmitter. Replace transistor with type 2N33 or 2N319 GE catalog number WT15X1. Replace battery with Mallory, blah blah blah. I believe this takes a standard 9-volt battery. I'm not 100% sure on that. And here it is. That sure looks like a 9-volt battery connector. And there is the lone transistor. It says 2N10. I can't really make it out. Sure doesn't look like a 319 though. And a handful of components. And looks like a regular 9-volt battery. We'll connect there. And we've got a couple rather long ferrite cores on there, and it looks like 1, 2, 3, 4 tunable slugs. I'm guessing that's for each of the 4 buttons. Down here, hopefully they're all engaging properly, otherwise I'll have to dismantle this and try cleaning it. Thought this was a couplet at first, in other words several resistors and capacitors combined into one component, but it does say 0.045 plus minus 10%, 500 volts. So that might just be a single cap. Got another one here. It's might be an early type of plastic cap, or it could be paper. Same with these 2 yellow guys up in here, and then there's a ceramic. Couple resistors. Alright, well hopefully all that's still good. Now this runs on very low voltage, even though they have a 200 volt cap in there, so even if this is leaky at say 200 volts, I think there's a pretty decent chance these caps will be fine at lower voltage, especially the ceramic ones. And these will be running so much lower voltage than they're designed to handle. I'm hoping that even if they are a little leaky at their full rated voltage, they'll work fine in this circuit. Okay, let's take a look at the schematic now. Okay, here is the schematic for the remote control for the M5 line from General Electric. So there's not much to it. This is a wired remote control version, so we can ignore that, and let's just look at this side. So indeed, that's a 9-volt battery. There's a single transistor. And there's, so I guess this one of the large coils is tapped. And depending on which function you select, it shorts out a different section of the coil. So in other words, it'll change this inductance, which should change the frequency of the oscillator. I believe this just sends out a single burst. Or probably it sends out a continuous wave, I should say. As long as you hold that button down, you probably get a single frequency being transmitted. So there'll be 4 discrete frequencies depending on which button you press. There's that one large flat ceramic looking cap. And there's the one that I thought might be plastic. The brown dipped cap. Here would be the 2 yellow guys. And here's the 2 resistors. And that would be the ceramic disc cap right there. And must be a couple others buried in here somewhere too. Now hopefully I'm not going to have to adjust any of this. You can see that each of these coils is tunable. I hope I don't have to mess with any of that. So the next thing I want to do is bring this into the workshop, and I hope I have a 9-volt battery handy. Otherwise I'll just rig up a DC power supply and clip it onto the leads, and then probe around with the scope and see if I can pick up a signal. I dug up a 9-volt battery, standard modern one, plugged it right in, fits no problem, and I just attached a clip lead to my scope probe, and it's just lying here. I'm going to see if I can pick up the transmitted signal, like so. So put my scope on a more sensitive range, to maybe 100 millivolts, and push a button, see what happens. Oh yeah, it's picking something up. Going through all 4 buttons. 2 on this end are especially strong. So I'm going to try holding a button down and then move the remote away and bring it closer. Alright, nice strong there. I'm going to turn down the sensitivity on my scope. Try that again. Yeah. A little noisy. Let's see. Try bandwidth a little bit. Get time up. See if we can measure the frequency on that. It's having a little bit of trouble. I think because there's noise in there. That's curious. It's not a continuous wave. It's actually, I don't think with one transistor you could make a pulsed output, but yeah. Huh, it's not continuous. You get a burst of pulses. Interesting. But it does appear to be functioning correctly. And I don't state anywhere in the schematic that I could see what frequencies this is supposed to do. Oh, huh. So these 2 buttons, the 2 volume buttons, are continuous, but on-off and channel are bursts. Or maybe I'm just not pushing the buttons hard enough. Okay, now it's doing bursts. And that one is too. Okay, I just wasn't pushing the buttons down hard enough, I guess. So yeah, it's a clever circuit that it can produce bursts of pulse with just a single transistor and a few discrete components. I'll try to rig this up better and hook the scope directly into the circuit, because I want to try to determine what those frequencies actually are. Okay, I think I found a good place to hook up the scope. Let's try this again. So this is first button. Now I noticed if I just press the buttons lightly, I get this continuous sine wave. But if I push the buttons harder, I get the pulsed mode. I'm not sure. Seems to me that you probably are meant to mash these down pretty hard, but it's curious that a light press would give you continuous wave. So I'm guessing there's two contacts under there, and you need to push down hard to make connections on both. Here's the next button over, so let's see. 326, 25, jumping around a lot. This one's about the same frequency, maybe just slightly higher. And, looks like they're all about the same frequency. So maybe as you're pushing this down, there's an initial contact that just kind of kickstarts the oscillator, and maybe when you press harder, maybe this frequency is different. If I go into manual cursors mode here, it's not able to figure out the frequency on its own, but I can manually position these markers. Alright, 327. The next one, push down hard. I'm getting the same frequency with every button when I push down really hard. So I'm wondering, maybe the difference isn't that. Maybe the difference is in these guys. So, let's see. Alright, so that's how one of them looks. There's another one. Distance between the pulses seems to be about the same. Scope's having a little bit of trouble triggering on this. So it's right about 3 full squares from the beginning of this pulse to the beginning of this pulse. Try another button. It is different. Okay. So this one's about 2 2/3 squares between pulses. Yes, but so is this one. Strange. Since those waveforms were a little confusing, I thought I would do a little more research online and see if I could find more information. So far, all I've found is this short article at the Early TV Museum about a control that was modified to work in an RCA color set. So here's a photo of it. Sure looks like what I have. And there's a link in it to brings up a little more info about it. In particular, it shows the transmitter. Now it says the carrier is around 200 kilohertz. And then it shows the modulating frequencies, which are very close together, which matches what I seem to be seeing. But I definitely don't have a carrier of 200 kilohertz. Plus, there's no other info here about how to adjust it or anything showing what the waveforms of what the output of the transmitter should look like. So I kept digging, and I found this eventually. Now, I thought this set might be too new to be in Riders, but I struck gold. In volume 27, the very last Riders TV volume, under General Electric, they have got more information than anyone should ever need to work on this set or this remote control. I'm just going to scroll down a bit to get to it. Alright, bear with me while I rotate this around. Some of the pages change orientation. Alright, here we go. General Electric Company preliminary service data. So it just made it into this. Wireless remote control and power tuning. U4 and M5 chassis. I believe my set has an M5 chassis. Alright, this has everything. And I do mean everything. Including the RF carrier frequency, factory setting, adjustable 322. In other words, just about what I saw. And here are the modulating frequencies. Now when I say everything, that's not exactly what I'm referring to. So we've got this voltage, current, frequencies, all the good specs on it. Also information about the receiver and what tubes it uses. Transmitter, here's the transmitter transistor rather, 2N319, PNP transistor, and so on. There's information about removal and servicing, and then it gets a bit more interesting. They go into theory of operation, and not just of how the remote control works. Transistors were pretty new back then, so they start out with basic semiconductor theory. So they go through this in excruciating detail of how semiconductors work, of how a PN junction works, of how a PNP transistor works, and so on. Finally, we get down to the transmitter, and it's a very clever circuit. With a single transistor, they're able to make both an RF oscillator and an audio frequency oscillator that coexist on the same transistor and forms AM modulation. And they do a rather clever thing in this service info. They isolate and break down the circuit to show you the two oscillators independently. So here is a simplified version of schematic with just the RF oscillator components, making it much easier to understand. And they go into theory here and explain exactly how it works. Basically, there's a tickler coil here that kicks back some of the energy back to the base and keeps the oscillator running. Alright, now as for the audio oscillator, this is a classic Hartley oscillator, which uses a tapped inductor to give you the feedback to keep it running. So this runs at a much lower frequency. Well, it turns out that the oscillation of this alters the bias enough that it affects the RF oscillator and forms AM modulation. And just as I had surmised that the large coil in conjunction with the push buttons forms taps on the inductor, which alters the frequency slightly. The four coils are connected in series so that in the final analysis, one large coil is available with 3 taps. That's how you get the different audio frequencies for the 4 functions. And also there are 2 switches inside there, and that's why when I would push lightly, I would just get the carrier, and if I push harder, I would get the AM modulation. There is a switch for power, and there is a switch for the individual button. You can see that on their schematic for the remote that shows more detail. So here is the initial switch that provides power and kicks the RF oscillator going. And then if you push harder, it's engaging one of these 4 switches. And here are the waveforms. So hey, that looks just like what I'm seeing. So I think this is working correctly as is. I'm going to leave it alone. I'm not going to monkey with it until I try operating it with the set. And there's parts locator. So if I ever do have any issues with it, this should be plenty of info to troubleshoot and hopefully repair it, including how to do our carrier alignment, audio frequency alignment, and how the transmitter operates. Here's a close-up of the receiver. I sure hope mine is functional, especially the reed relays and the motors. So each one of these reeds is tuned to one of the modulating frequencies. You can see the 4 frequencies indicated here. They vibrate at that frequency, which causes the reed relay to trip or make contact. I imagine it's vibrating, so it's making just momentarily contact, but that's enough to trip these down here. In fact, it even says they are sensitive relays. So this vibrating here and making momentary brief contacts here is enough to trip these, which then control the reversible motor for channel, and I'm not sure what they use for volume. I think it's this latching relay. No, that must be the on-off. Is the latching relay to turn this set off and on. I'm not sure how they do volume. Probably something similar to what my Admiral portable remote control set uses, which is a latching relay. Each time you trip the relay, it advances a gear 1 tick. So like each click on the remote goes the volume up 1 step, 2 steps, 3 steps, 4 steps until it gets to the end. And the reversible motor is the channel up and down. Now my friend I got this set from has operated this motor, so I'm pretty confident this works okay, because there are buttons on the front of the set to turn the channels up and down, which also engage this motor, and he said that was operating. Now all is not lost if these reeds aren't working properly. Not that I could find a replacement, that seems very unlikely, but I did get a comment from someone who had, or maybe still has, this set, and it had a bad relay assembly, and what he did was use an NE567 integrated circuit, which is a tone decoder, I believe, designed originally for touch-tone telephones, DTMF decoder, and he was able to rig it up so it would trip on each of these 4 frequencies, and you could drive the relay with that. So if this assembly is shot, there is a workaround, so that's good to know, but I'm going to keep my fingers crossed that mine is still functional. Now, I hate to do this to you because I know you all want to see the TV operating with this remote control, but it's still out in the garage. I need to clear some room for it before I can bring it up inside, pop the back off, and check it out. Hopefully I will clear some room soon and get some help and get this set up inside and do that in a separate video, but for now, that is going to be it. I hope you enjoyed this look at a General Electric RF remote control from 1959.